All right, so this particular video is about graphing attribute of absolute value functions and how to write them. So we're going to start off, I'm going to show you three basic things. One, the different parts, the vocabulary part of it. Then I'm going to show you how to actually write them with notations, and then how to plug it into the calculator. Okay. So the first thing is the vocab part of this. So the ones you are familiar with at this point are the x-intercepts. So this point and this point here, or a different color. This point and this point here would be considered your x-intercepts. This is a one shot, so hopefully I don't mess this up, by the way. So x-intercepts. Okay. You also know this point right here as your y-intercept. And again, those are the two places where the graph actually crosses each respective axis. Okay. And I can't spell. So your y-intercept crosses your y-axis, your x-intercepts cross your x-axis. Okay. Your vertex may be new depending on what you remember, but your vertex essentially is this point right here. Okay, and that's going to be a very important point when we start writing equations later on. And we're going to call this x and y. When we start writing equations, we're going to call this h and k later on. Okay, so just letting you know. Then we have your domain and range, and then we know your domain. Your domain is going to be your x values. We know your range are going to be your y values. Okay. And in this case, what you're going to notice are these arrows here, which this one right here kind of disappeared. I'll draw one right here. You can see it a little better. And that way you know that these graphs do go on forever unless we have stopping points of equality or non-equality. But we'll get to that a little bit later. So then the new vocabulary, increasing and decreasing intervals. Okay. So the best way to explain what these two items do is for me to actually draw it and show you what it does. And I can't find a different color highlighter that I want. But anyway. So your decreasing interval is going to basically go down, and it's going to decrease in y value. Okay. So this right here is what we will call a decreasing interval. Okay. And again, it's because your y values are decreasing. So if I start from here and I work my way down this way, your y values are going from 3 all the way down to -4, it looks like. So then that's going to be a decreasing interval. On the flip side, you have something called a or an increasing interval. Okay. And again, for the same reason, your y values are increasing. So if I'm starting at -4, working my way up, your y values are actually increasing. Okay. And that's what you kind of need to know about increasing and decreasing intervals, is the fact that where they exist and how to write them. Okay. And I'll get to the writing part here in a second. The last part, and it's a little bit more complex. It's easier to understand when I write these. In behavior. Okay. So your in behavior deals with the two right and left parts of your graph. Okay. And the best way to describe what in behavior is as your x value decreases or increases, depending which side you're on, what does your y value do? Okay. And that's what in behavior actually is. So as your x value is going this direction like this, what is your y value doing here? So like here, in this case, my x value is decreasing, while y value is actually increasing. On this side, my x value is increasing, my y value is also increasing. Okay, and I'll show you how that works. And the cool thing is there's only 4 options for this. So that being said, the one thing I want you to do with these all the time to help you out with these two particular concepts is this. If you draw an infinity symbol here, an infinity symbol here, a negative infinity symbol here, and a negative infinity symbol here, that'll help with your in behavior, because if x is going this direction, y is going this direction. If x is going this direction, y is going this direction. Okay. So that's your basic vocab for this unit. So now how do you write the actual attributes? Well, vertex is a coordinate, which makes it nice. So your vertex is an actual coordinate. So like in this case, my vertex here is going to be this point, which would be -2, 0. Okay. I'll come back to the increasing, decreasing in a second. My y-intercept, my x-intercept, again, where it crosses the x-axis, happens to also be my vertex in this case. So I'm going to write it as a coordinate also. My y-intercept, again, if I look here, crosses right here at this point, which happens to be 0, 2, and it's also written as a coordinate. Now, one thing I'll say about x-intercepts is that you may not always have one, okay? And you'll see one of those in one of the examples or in your assignment, depending on what you're doing, okay? We're not going to do transformations right now. I don't know why I left that on there. Your domain, and again, if we look at this, we have these two guys right here. Well, if I'm going from this to here, this direction, if I'm going from this point to this point, and I know that my graph goes on forever, well, I know my graph on my x-axis is going to go from -infinity to +infinity. And if you remember from the last lesson, because they're infinity symbols, we're going to use parentheses on those guys. Your range, which are your y values. And again, I know my graph starts right here at this point, which happens to be 0 on the graph. And it's going to go up this direction here. So it's going to start here at 0, and it's going to work my way up this direction. And again, I know it's going to go from 0 to infinity with a bracket on the 0, because that point indicates equality, or that it works. Okay, that's included. Now for the new part, the increasing, decreasing intervals. So here's the thing. You need to know the vertex to write this. So you need to know the x on the vertex to write this. Okay. So what happens is this. If I'm starting at this point here, right, I'm going to work my way from here, and I'm going to go all the way down until I hit this vertex point right here. Because at this point, my graph is going to shoot back up this way. So at this point, I know I'm going to work my way down this direction. And then I know at this point, I'm going to work my way up from this direction. Okay. So we know that if we're going forever this direction, and this is one of those where you have to understand that this graph goes on forever, then I know if I keep walking from out here from infinite, I'm going to come down and eventually hit a vertex point and then start working my way up and work my way back towards infinite. Okay. So your increasing interval would actually go from -infinity all the way until you get to that vertex point. Okay. And it's important because these are based on your x values. So it's going to go all the way to -2. So what happens at -2? Well, at -2, you reverse course and you go back up again. Okay. Which is what you're, you know what? I wrote this backwards. This is your decreasing interval. No, I don't need whiteout. This is your increasing interval. That was my fault. The one thing is I didn't actually read my own words. So it's decreasing from -infinity to -2, and it's increasing from -2 to infinity. And again, that's because you're going from -infinity to -2, and then from -2 back to infinity on your x-axis like this. Okay. Now, because this point is an actual vertex point, there's always some kind of debate on how you write these as notations. And you use parentheses because of the fact that at the actual point -2, 0, you're essentially stopping. There's no increase or decrease. So everything up to -2, you either increase or decrease, but once you get to the actual point or vertex, you actually are not doing either. So we use parentheses to indicate the fact that we're doing this up until -2, and then after -2, we're starting back up again. And I know that's a little confusing, and I understand that's why we practice these over and over again. But for right now, if you can at least tell me how to write this, I think we'll be okay moving forward. Okay. That being said, the in behavior, and this again is one of those where I always say write your two symbols like this, and here's the reason why. Because in behavior looks something like this. Okay. As x approaches -infinity, comma, y, or f of x, depending on how we write it, approaches infinity. Okay, that's one. I'm gonna write the second one, and I'll explain to you exactly what I'm doing. As x approaches positive infinity, y is approaching positive infinity. So here's what this means. So this is what we call the left bound or the left side, and this is what we call the right side. If I look at my left graph right here, and this is where it gets interesting. This arrow is going in this direction. What's happening is this, it's got two components, and I wish you were already in pre-cal because pre-cal talks about vectors, but basically it's got a horizontal and a vertical vector. So horizontally it's going on the x, vertically it's going on the y. Okay, so it's going this direction on the x, going towards -infinity, and when it's doing that, it's going this direction on the y towards positive infinity. Hence why it says as x approaches -infinity, y is going towards positive infinity. Okay. On the right side, which is this side over here, so this is my left side, this is my right side. As x is approaching positive infinity, so as x is going this direction on my horizontal vectors, my y is also going up, which is what creates this particular arrow like this. Okay. If you're in physics, you haven't done vectors, this is kind of what you're dealing with. But again, that's the whole reason why it's written this way. Now, some people will write this backwards, where they'll write this first followed by this. You know, I'm not a big, it doesn't matter to me how you write it. What matters is the fact that you describe or indicate what x is doing and what y, or in some cases, f of x is doing, okay, on each side. So that's how you write all of this. Okay, you're still using parentheses and brackets, and again, if you're a little confused, I would go back and rewatch this one more time to try and get it, because you're going to use these symbols all year long. Okay, so now what happens if you don't have a graph? So we got to figure out how to actually graph. So in a calculator, now this would be the same thing on your calculator app. The shortcut to an absolute value is basically this. If you hit alpha, you should have an A pop up. Window, the first thing that says is ABS. ABS stands for absolute value. And then you should have two bars that look like this. So now what I'm going to do is I'm going to go through and fill some things out. So one thing I'm going to show you is the insert button, this INS button. If I hit second insert, I can actually drop that 3 in, like you have in your equation here. Then come in here and go x plus 2, and then minus 5. Okay, that's how you plug it into the calculator. So now I'm going to go into my y equals and do this. And again, I'll do it again. That's why I didn't do it the first time, so you can kind of see it. So alpha y equals, and by the way, yeah, you could, alpha window, absolute value. And again, if you want to learn how to use the insert button, this is a good time to do it. You could always type the 3 and then do that piece. Okay. So this is what I'm going to use. I want to fill out my table real fast to do this. Okay. So again, if you don't know how to do the table, that's fine. You go second graph to get your table, and it looks like I want to start at -4. So it looks like -4 is 1. -3 is -2. -2 is -5. -1 is -2. 0, 1, and 1, 4. Okay, just like that. Now I can graph these points. There's that one. There's that one. There's that one. There's that one. Now notice how there's a point missing here. You could probably guess where the point is at. There's a thing that I realized that we're not talking about. It's called the axis of symmetry. But there's a point right here also, even though it's not on our table. And there's also a point right here because there is a symmetrical line that runs through like this that you don't ever see called the axis of symmetry. And it's always good to know that because you'll actually see that later on in one of our units even more often. Okay, and that's how I know where these points actually are if they don't show up on the table. Okay, so now I'm going to go through my pieces. I'm going to graph it, and because this is not discrete information, I'm going to go ahead and connect my points to while I'm at it, like this. Okay. Now at this point, if you want to pause it before I go through this part and try to do it yourself, now would be a good time. All right, I'm back. So the first thing is your vertex, which is this point right here. And what's nice is I can also find it on my table because of this right here. So my vertex I know is -2, -5. I'll come back to those two in a second. My domain, if you have not figured this out by this point, for absolute value, as long as you have these arrows showing, it's going to be -infinity to +infinity for my domain. So that's kind of nice. My range, my low value here is -5. Okay. And if you haven't figured this part out yet, your range is based on your vertex value. Okay, so I know it's going from -5 going up. And again, solid point. X-intercept. So the funny thing is on those, they're not exact. I know they have them here and I know they're here. They're not exact. And there's a way to find them. We haven't done solving yet. So I'm going to do them in a calculator here. If I go back to this graph, I want to find that point right there. And again, I'm going to do a second trace. And I know x-intercept is also known as a 0. And then I'm going to go my left bound, my right bound, and then I'm going to guess that x-intercept right there. So it looks like -3.67. 0. And then the other one, again, second trace 0. And if you haven't watched the videos on this, you might want to. This is one of the prior lessons that we've kind of already gone through. It looks like -0.33. Because it's very important to be able to use a calculator to find them if you can. My y-intercept is 0, 1. So that was pretty straightforward. Okay. Now my increasing and decreasing. And again, this is my decreasing, it looks like. Looks like this is my increasing again. Okay. I'm going to make sure I read it this time. Increasing, so from here to here, it looks like it's from -2 to infinity. Decreasing, it looks like it's from -infinity to -2. Okay. All right. In behavior, last one. Again, infinite, infinite, negative infinite, negative infinite. So in behavior, so as x is approaching negative infinite, y is approaching, looks like infinite. So as this is my left side, my right side, x approaches positive infinity. Looks like my y is going up also, so that would be infinite. And really truthfully, I should have used f of x, that was my fault. So this should actually be f of x, and this should be f of x. No real change in the answer, just how I wrote it. Okay. So you have one more to do, to try, to make sure you can do it. And again, I'm not going to talk a whole lot of this one, I'm just going to do it. So if you want to pause and do it before I do, go ahead. All right, so where's my pen at? So my table, it looks like I'm going to be using, what am I using here? What do I have? So my vertex looks like it's a 3 something. Yeah, so I'm going to use 3, 4 as my vertex. So 3, 4 is my vertex. Then I'm going to go and use 2, 5, 4, 5, 5, 6. And then how did I decide these things is because, and I'm going to put 0, 7. Because 0, 7 also happens to be my y-intercept. Okay. So when I graph this, I have 0, 7, which is actually off the graph. That's fine. 2, 5, 3, 4, 4, 5, and then it looks like the other one is 5, 6, which is right here. So when I graph this, it looks like my graph does this number like this. Here's what that tells me. This graph particularly does not cross your x-axis. So right off the bat, I don't have any x-intercepts. So that's nice. My domain, and again, because this graph goes forever, this graph goes forever. My domain, I know, is still going to be negative infinity to infinity. Range looks like it starts at 4 and it goes up. So it's going from 4 to infinity. Decreasing and increasing. And again, I'm going to look at my graph. This is going down this direction. And I know before you ask, well, it's on a different part of the graph, your numbers are positive. It doesn't really matter because you have to really assume that this graph goes on forever in this direction, which means it goes into this realm of negatives eventually. Okay, if I would have kept graphing it. So that being said, I know it decreases going this direction. So from negative infinity to 3, it's going to decrease. And then from 3, it's going to increase to infinity on the x. Okay. My end behaviors, my 2 infinities, my negative infinity, my negative infinity. And again, this is where you got to be very careful. So as my x is approaching negative infinity, okay, this direction, my y is going up. So my y, yeah, or my f of x, well, this is my fault. F of x and y, one of the things I have to make sure is that these two match all the time. That's just an annoyance on my part. F of x is approaching infinity. As x is approaching positive infinity, this direction, my y is also approaching, or my f of x is also approaching positive infinity. Okay. So that's that. And again, go back and watch these, or try them and watch them before you do it. It's very important because here's my final thought on all this. This is what we're going to jump into next. If you were to change the shape of the graph, how would the attributes be affected by those changes? So in other words, if I was to take a graph like this and all of a sudden, let's just say it's upside down, you know, how does that change your end behavior? How does that change your increase and decrease intervals? Things like that. Okay. So that's just the final thought. All right. So you got an assignment now. Go look at it. You got a quiz before you take off. And other than that, I'll see you around. Peace out.